Hey students, today we are going to be covering chemistry chapter number 1, atoms, molecules and chemical arithmetic. Today we are going to be covering the topic 1.1, scope of chemistry. As you can see here, I have two parts on my screen. The first one is the textbook. The second one is the notes, or what we are going to be forming, what we're going to be learning. Just for you to understand, I'm going to be explaining this way. Okay, so before we start, we need to understand what scope of chemistry is. What does scope of chemistry mean? What do you mean by scope? Scope means variety or aspects or ways. And what is scope of chemistry? It means different ways that chemistry helped us in our daily life. Okay, or not in our daily life, or just in generally aspect of life. How did chemistry help us? Now, the scope of chemistry, we have many scopes of chemistry. If you look into this topic, you can see that we have so many scopes of chemistry. But today we are only going to cover 4 scope of chemistry, which is given in your textbook. Your textbook only gives us 4 scope of chemistry. So we are only going to be covering 4 scope of chemistry. What are the 4 scopes of chemistry that is covered in your textbook? The first one is health and medicine. Health and medicine. The second one is energy and environment. The third one is material and technology. Material and technology. And the fourth and the final one is food and agriculture. So these are 4 ways that chemistry helped us in our life. Let us start with the first and the foremost one, which is health and medicine. Okay, we'll start with health and medicine. Now, in health and medicine too, I'll just write it real quickly here, and medicine. Now, in health and medicine, chemistry helped us in total 4 ways. According to your textbook, 4 ways are mentioned. Okay, so there are 4 ways that chemistry helps us in health and medicine. What are the 4 ways? Okay, the first way that chemistry helps us in health and medicine is the development of sanitary system. Okay, the development of sanitary system. What does sanitary system means? Hygiene, sewer system, water system, etc. So you can say chemistry helped us develop such systems which protected large populations from getting diseases. So the development of sanitary system, sorry, I did not write here sanitary, I'll just write sanitary real quick. The development of sanitary system helped large population protect itself from what? Major diseases, which saved a lot of lives. Okay, the second one is surgery with anesthesia. Surgery with anesthesia. Surgery with anesthesia helped doctors operate and cure fatal conditions such as inflamed appendix, etc. Then we have vaccines. And antibodies. Vaccines and antibodies helped to prevent diseases caused by microbes. It also helped in many different ways. And finally, we have gene therapy. Gene therapy, which is also considered as the 4th revolution of medicine. Did you know that many of the diseases that occur, or many conditions of the in the earth, occurs due to damaged genes? Okay, due to damaged genes. For example, we have cyst fibrosis, hemophilia, cancer, heart diseases, arthritis, AIDS, etc. They're all from damaged genes. So, gene therapy. What is gene therapy? So, what do doctors do? Doctors, they take a good healthy gene and they introduce this healthy gene into the patient's body. Okay, they take a healthy gene and they introduce it into the patient's body. In order to do that, this helps. What does this do? This just helps us prevent, or it also helps us cure such diseases or disorders. But in order to do such a treatment, in order to learn how to put the gene inside the in the patient's body, not the parent, sorry, in the patient's body, doctors need to have basic knowledge of chemistry. Also, chemists help us in health and in health and medicine. Chemists helps to create drugs or medicines which can treat cancer, AIDS, organ transplant, and also increase lifespan. Okay, so that is chemist's role inside health and medicine. Now we can jump to our next heading, which is energy and environment. Energy and environment. Okay, now how is energy formed? Energy is the byproduct. What is energy? Energy is the byproduct of many chemical reactions, a series of chemical reaction. The demand of energy is increasing. Okay, the demand of energy is increasing. One thing we need to know in today's world is that the demand of energy is increasing. It's increasing a lot in both technologically advanced countries such as the US and also in the developing ones such as India. Now, currently, the major source of energy, in order to get energy currently in today's world, the major source of energy is burning of fossil fuels. Burning of fossil fuels. Okay, burning of fossil fuels is right now the major source of energy. Okay, what are fossil fuels? Fossil fuels are coal, petroleum, natural gases, etc., etc. Okay, now these reserves, one important thing is that these reserves are ending. It is not permanent. They're not there forever. It is estimated that in 50 to 100 years these will finish. At current rate of consumption, these fossil fuels will finish. And if we do not find an alternative, if we do not find an urgent replacement for fossil fuels, then we will not have energy. And energy supplies a lot of things in our daily life, which is a very, very dangerous major issue in our current world. So we need to find an alternative. There is an alternative, and that is solar energy. Okay, there is an alternative which is solar energy. Solar energy is the most viable source of energy. Okay, it is always available and is the most viable, widely available solar energy. What happens is that every year the Earth's surface receives 10 times as much as energy as contained in all known reserves. Now we had no fossil fuels and all. The Earth receives 10 times the energy from the fossil fuels. More than the fossil fuels, the Earth receives 10 times the energy. Okay, but what happens is that these energy, that the solar energy received by Earth, is wasted. How is it wasted? Because if this is the Earth here, okay, suppose this is the Earth, okay, and this is the sun is, solar energy comes from solar ray, right? So when the solar ray hits the Earth, when the solar energy hits the Earth, what happens? It gets reflected back. It gets reflected back, and this reflecting back to space is a huge waste of solar energy. It's such a waste of solar energy. Okay, now ways to harness solar energy. Harness means to keep solar energy. Since it keeps going back into the space, we need to directly convert it into energy, because solar energy can't be just directly, you cannot just use sunlight as energy. You need to turn the sunlight into energy. So there are ways to harness solar energy. Ways to harness solar energy. There are ways to harness solar energy. Okay, there are two ways to harness solar energy. There are how many ways to harness solar energy? There are two ways to harness solar energy. The first one is conversion it's the conversion of sunlight directly into electricity. Directly into electricity. Solar energy comes from what? From sunlight. So the first way is the conversion of solar energy directly into electricity. Okay, using, you cannot just change it with your hand, right? You need to use something. So using what? Photovoltaic cells. You can convert sunlight directly into energy to get photovoltaic cells. So this is the first way to harness or to use or to conserve solar energy. The second way is that using sunlight. We can use sunlight, okay? We can use sunlight, using sunlight to obtain H from H2O. H is hydrogen. So we can use sunlight to obtain hydrogen from water. And we can feed this hydrogen. We obtained hydrogen, right? We can feed this into a fuel cell. Okay, we can feed this into a fuel cell to generate electricity. Fuel cell, they take hydrogen and they turn hydrogen into they take a hydrogen and they turn it into electricity. So we can use sunlight to take out H from H2O, which is water, and we can feed this into a fuel cell and we can harness energy. Okay, now solar energy is good and all, right? It's really nice and it's really amazing. So why are we not using solar energy right now? Right? You said, you're like, ma'am, you said that solar energy is really nice for the earth and we are using fossil fuels right now. Why can't we just start using solar energy? The thing is that there's a huge disadvantage for solar energy. There's a huge disadvantage. For today's time, there is a huge disadvantage for solar energy. What is the huge disadvantage? It is one word: expensive. Solar energy is expensive. What do you mean expensive? Although we have understood how to use solar energy, we have learned its process, we have understood how to convert sunlight into electricity, we have learned a lot of things, we have learned this, right? But although our knowledge has improved, but the technology is not yet improved. The technology is not yet improved to the point where we can develop electricity on a large scale in an economically acceptable cost. So we cannot turn sunlight into electricity in a very cheap rate in today's world, because the technology is not advanced. Now there we have a prediction though. By 2050, it is predicted by 2050 that at least 50% of our need will be supplied by solar energy. This is the prediction, that at least by 2050, 50% of our electricity or energy need will be supplied by solar energy. But that's just a prediction. We'll have to see at 2050. Okay, you tell me in 2050. Okay, now we have another way. So we have seen fossil fuels, right? These are the ways energy is harnessed. The first one we have learned is fossil fuel. The second one we learned is solar energy. there is a third alternative way. Third way that this energy is conserved or what is by using nuclear energy. This is done by the process of nuclear fission. By nuclear fission, we can harness electricity or energy. But the thing is that when we do the process of nuclear fission, the thing is that there's a lot of radioactive waste. When you do nuclear fission, there's a lot of radioactive waste. This radioactive waste from fission process is a really huge concern for the environment. So the future of nuclear industry is unknown and it's very uncertain. The chemists can find ways to solve this by finding safe way to get rid of radioactive waste. Maybe then nuclear energy will be a very famous or a better option for energy, but that is still unknown. Now, though we are using fossil fuels, though we are burning fossil fuels, there is a huge advantage of burning fossil fuel in today's world. What is a huge advantage of burning fossil fuels in today's world? In today's world, even though we are using fossil fuels, we are burning fossil fuels. These fossil fuels, which is burning coal, what else are fossil fuels? We are burning coal and we are burning uranium, etc., petroleum, natural gas, etc. What happens is that they release carbon dioxide. Okay, they release carbon dioxide, sulfur dioxide. I think you guys have heard this. We are learning this from 5th grade. Okay, sulfur dioxide. Then what else? Sulfur dioxide. Then we have nitrogen oxides. These are called green gases. Okay, these are called green gases. Okay, and these green gases, what happens? They're bad for the atmosphere and they deplete the ozone layer. Okay, and what happens? This results in acid rain and smog. So burning fossil fuels is really bad for the environment and it's a huge disadvantage, but we don't have any alternative for right now. Though we have solar energy is a bit too expensive, so using energy right now is very, very difficult. So we have to stick to fossil fuels hopefully until 2050, because fossil fuels give carbon dioxide, sulfur and nitrogen oxide. This results in acid rain and smog, and these three gases are called green gases. We have solutions though for this. Again, what are the solutions for burning fossil fuels? We have solutions. Again, we can use solar energy. Okay, we can use solar energy. The second way we can do is, why can we use solar energy? Because harnessing solar energy has no bad effect on the environment. Okay, the second way we can use fuel efficient vehicles or automobiles or mobiles. What does fuel efficient means? It means that the engine or the emissions given out will be cleared or will be clean. So when they reach the atmosphere, they don't have carbon dioxide or they don't have nitrogen or they don't have sulfur oxide, and they'll be very clean and they will not affect the atmosphere. Okay, and also third way we can use is electric cars with long durable batteries, which should be prevalent, which should be available by 2050 or the next century. Okay, and now we can go and finally move on to our next topic, which is material. This is the third topic here, material and technology. Look at here, we have covered all this. Right, now we can forward to material and technology, which is the third of our topic. Now, material of technology. Okay, we just need to know more about electricity. Right now, currently electricity currently electricity, what happened to electricity currently? Currently electricity is being transported from power plant. Okay, this is a power plant. Power plant is where electricity is all generated. It is being transported from power plant to our houses, using CU cable, which is copper cable. Okay, copper cable. They use copper cable. The thing by using copper cable is that 20% of the electricity which is being transported is wasted in the form of heat. It is wasted in the form of heat, which is a very huge loss and very tremendous loss. In order to find a solution for this, we need to find some sort of superconductor. Copper is a conductor of electricity. That's why we are using it to transport electricity from the power plant to our house. But 20% is lost. In order to save that, we need to find a superconductor. What is a superconductor though? A superconductor is a material which has no electrical resistance. Okay, why does this turn into heat? Why does electricity turn into heat? Why does the 20% electricity? Because of electrical resistance, and therefore this superconductor, they do not have electrical resistance, so that means they can conduct electricity. They can conduct electricity without any energy loss, no energy loss. But the thing is that there is no such material as superconductor. It's just in our imagination currently, right now, but maybe in the future some sort of material might come out which is a superconductor. Now finally, in the final topic or last final heading, which is food and agriculture. We have food and agriculture. The last topic is food and agriculture. Now let us understand fourth topic. Now let us understand about food and agriculture. Food and agriculture in poor countries right now in the world, in poor countries, around 80% of its population rely on agriculture. Agriculture means farmer activity or farming, plowing, etc. is agriculture activity. Okay, right now 80% of poor countries means in 80% in poor countries, 80% of the population they rely on agriculture. 80% they rely on agriculture, and about half of the wage, half of the money, or half of the family budget is spent on foodstuff. This is a huge, tremendous drain on the nation's resource. The 80% of the poor countries, they depend on agriculture, and half of their money is going on foodstuff. So that's a huge, tremendous waste. Okay, now that's all for food and agriculture. We just need to understand how chemistry affects agriculture production. So factors that affect factors that affect agriculture. We just need to understand what are the factors that affect agriculture. Okay, factors that affect agriculture are, we have total 6 factors that affect agriculture. Okay, total 6 factors that affect agriculture. The first factor that affects agriculture is, what's the first factor? Is richness of soil. Okay, richness of soil. If the soil is really good with fertilized soil, if soil is really good, then the plant also will be good, obviously. Then insects, if insects come and they eat the plant, then the plant will die. That's very normal. Then we also have diseases that affect plant. We have diseases that damage crop. If a plant is sick, then they will not give crop, obviously. Then we have weeds that compete for nutrition. If you have weeds, what are weeds? Weeds are those unnecessary plants that grow in a farm. Okay, unnecessary plants, they just take nutrition from the plant and they kill the plant. Okay, and then we have irrigation. Irrigation means water supply. If there's no water supply in some plants, then they will die. If there's more water supply in some plants, then they will also die. So it depends. And also finally, farmers rely on fertilizers and pesticides for increasing crop yield. So farmers rely on fertilizers and pesticides to increase the crop yield. So these 6 are the factors that affect agriculture. And by this we conclude our topic, which is chapter number 1, atoms, molecules and chemical arithmetic, first subheading, scope of chemistry. Here I have written down very roughly, but if you want, watch the video again and slowly by pausing in between, and you can write this neatly as a note. I have covered everything that is available here, and I have tried my best to write neatly. Not really, but this is it. Okay, thank you.